Alright, this is going to be part 2 of completing our unit circle, and in the first unit circle video I went through and I filled this circle in terms of degrees and as well as in terms of radian value. And the next thing that I want to focus on is finding what these coordinates are. Remember, the unit circle, just as kind of a refresher, is a circle with radius of 1. And more specifically, just to add on, it's centered about the origin, which is 0, 0. Alright, so if I have a radius of 1 and I'm starting at 0, 0, imagine this is my x and my y-axis. If I start at 0, 0 and my radius is 1, what would this coordinate be? If I go over to the right 1, it would be 1, 0. The one, if I start at my origin and go to the left, I would be getting negative 1, 0. If I go up to 90 degrees, I would be getting 0, 1, and finally 0, negative 1. Now, those are the 4 main coordinates, but if you notice, we have all these other ones right here. And I'm going to focus primarily on this first quadrant and show you how to derive these values. You don't have to derive this every time, but it's useful to know where they come from. If you can imagine what I'm going to do to find this coordinate right here, I'm going to take out a piece of this circle. Alright, I'm going to cut out a little right triangle. A little right triangle. It's going to be a 30, 60, 90. Remember, this is a 30-degree angle right here. So I'm going to bring that over here. And if you remember from the first video, our sample 30, 60, 90 does something like this. If our hypotenuse is 2 times x, then the side opposite 30 degrees is exactly half of that, so that would be x. So if I want to find the side opposite 60 degrees, I take x and I multiply it times square root of 3. Now, if I want to find my coordinates for the 30-degree angle, here's my 30, 60, 90. The one thing that I happen to know on my unit circle right now, because I know my radius is 1, if I start at the center and go to any point on this circle, I know that my radius is a length of 1. If I fill that in, if my radius I know is 1, the side opposite 30 degrees is going to be exactly half of that, so that's going to be 1/2. And in order to get the side opposite 60 degrees, I'm going to multiply that times radical 3. 1/2 times radical 3 is simply radical 3 over 2. So imagine I'm starting at my 0, 0, and I'm going over to the right, radical 3 over 2, whatever that decimal value is, and I'm going up half a unit. So those are my coordinates. Those are my x and y coordinates right now. Radical 3 over 2, 1/2. Now, if you happen to do a 60-degree angle, if you focus on the 60-degree angle right now and draw yourself a right triangle, the same thing is going to happen, except it's going to be flipped. Imagine you have a 36, it's going to be a 60-degree angle, but what this is really showing you is it's still a 30, 60, 90. Remember, your hypotenuse is still 1. The side opposite that is going to be 1/2. And then 1/2 times radical 3 is radical 3 over 2. So all that really happens is you flip-flop the coordinates, and instead you have your x coordinate being 1/2 and your y coordinate being radical 3 over 2. So let's fill that in as well. Here's 1/2, radical 3 over 2. The last one that I have to figure out is this pi over 4. What is that coordinate? And if you notice, this is a 45-degree angle. Let's use our 45, 45, 90 properties. Again, we're going to cut out a little piece of this triangle, or a little piece of the circle rather, and it's going to help us figure out what our coordinates are. Here's my 45, 45, 90. And remember, my radius is still 1. The sample 45, 45, 90 looks like this. It says x, x, x radical 2. But if you notice right now, my hypotenuse is 1. Okay? If you want to solve for what this x originally was, I would have to set 1 equal to x radical 2. If you solve for x, setting up your equation, x radical 2 equals 1, you divide by radical 2 on both sides, and you should get x equals 1 over radical 2. But remember, you have to do a little thing called rationalizing. So you multiply top and bottom by radical 2. Radical 2 over 2 is your x-coordinate. Now, if you notice, your x-coordinate and your y-coordinate are going to be the same. If you notice 45 degrees and 45 degrees, they're going to have the same length. X equals the radical 2 over 2, y equals radical 2 over 2. And let's fill those in. Once you have this first quadrant filled in from 0 to 90, everything else should be pretty easy to fill in. If you notice, I have a 150 degree angle here, but I could automatically fill in the rest. This would be a 30 degree angle right here. And the same thing would apply. I have my 30 degree angle over here, and I would force myself to draw a 30, 60, 90 triangle. But instead of doing that, I know my coordinates here. The only thing I need to worry about is sign changes. So at this coordinate for 5 pi over 6, what coordinate is going to change signs? Remember, if I go to the left, I'm talking about negative x values. So instead of saying radical 3 over 2, it becomes negative radical 3 over 2, comma, 1/2. As well as radical 2 over 2 here for my x-coordinate. That will also become a negative radical 2 over 2, comma, radical 2 over 2. And finally, this one right here will become a negative, sorry, should probably make that positive, negative 1/2, comma, radical 3 over 2. That's going to be our second quadrant. Our third quadrant is going to be going to the left and then down. So both of these are going to be negative. So again, 210 degrees, if I fill in the rest of this angle, that will be 30 degrees. Okay, so equivalently in that location, I would have negative radical 3 over 2, comma, negative 1/2. And we can just keep filling our unit circle in. If I know my pi over 4 is radical 2 over 2, comma, radical 2 over 2, my 5 pi over 4 should be negative radical 2 over 2, comma, negative radical 2 over 2. And finally, my 4 pi over 3 should be negative 1/2, comma, negative radical 3 over 2. Finally, on my last quadrant, my x-coordinates are going to remain positive because I'm going to the right of my origin, but then I'm going down on my x-axis, which is going to give me negative y-coordinates. My radical 3 over 2 will remain the same, but instead I'm going to have negative 1/2. And my radical 2 over 2 is going to be the same, but I'm going to get negative radical 2 over 2 for my y. And finally 1/2, comma, negative radical 3 over 2. And at this point you have filled in your unit circle completely. So if someone asks you what cosine of 30 degrees is, or cosine of 45, cosine of 60, you could go through the process and do cosine, which is adjacent over hypotenuse, and find your actual coordinate. But what's really going to happen is, if we focus on this 30 degree angle, let's go back to this really quick. If I ask you what's cosine of 30 degrees, remember cosine is adjacent over hypotenuse. So all I'm really doing is taking my radical 3 over 2 right here and putting it over 1, since my hypotenuse is always going to be 1. But that's simply radical 3 over 2. That does not change. And same thing for my sine. So if I ask you for sine of 30 degrees, what are you really doing? Sine is opposite, which is 1/2, over your hypotenuse, which is 1. 1/2 over 1 is 1/2. Now, the easy way to remember this is anytime someone asks you for cosine of 30 degrees, 45, 60, 90, anything on your unit circle, all you have to think about is cosine of x will be your x-coordinate, and sine of x, of whatever angle x is, will be your y-coordinate.